Right. Good afternoon. Assalamu alaikum. Shall start now. So we started the unit number 10 in the last class, and I give you some words to read. You guys have you done exercise? Now going. Other half I have. Right. Look at the questions, please. The power of an electric water pump is 750 watts. Calculate the current drawn by the motor if it is connected to 230 voltage supply. So the first question, A. Whom do you want to find out? You want to find out the current. Can I tell me the formula? What is the formula connected here? P is equal to V into I. Power equals voltage into current. Voltage into current. And you want to find out the current here. So you have to rearrange the formula. You have to show that I is equal to P over V. I is equal to P over V. What is the power given? Power given is 750 watts. 750 watts dividing by 230 voltage. What is the answer? 3.26. 3.26. 3.26. What is the unit there? Amperes. 3.26 amperes. Right? Please check with your answers. If it is wrong, correct it. Those haven't written, quickly write them down. Okay. Number 2. State one type of energy other than the kinetic energy generated when the motor is operating. Now, whenever we are converting these energies from one form to another form, okay, some of the energies will be beneficial. We will use them. We will consume them. Some energy transformations are there which are wasted, which are lost out. Okay. So more the energy is lost out, efficiency will be reducing. 100 units of energy is the input. You are using 70. 30 lost out means your efficiency of the machine is 70%. You are using only 30. 70 lost out means efficiency is just 30%. 70% lost out. And the losing out energy may be in different forms, mostly as heat. The motor here, when it is rotated, it will be heated up. Do we use the heat energy there? No, we need the motor to rotate. So kinetic energy is what we are consuming here. So the heat energy we don't use, it is a loss. And it produces a sound. Do we use the sound? Are we using that sound? No, right? It's a waste of energy. Producing sound in the form of sound energy. So that is also a loss of energy. So sound energy also it could be lost out. Some conversions are there where it would be producing a light, which we don't use. So if you are not using, it's a loss of energy. And here the answer should be either the heat energy, or you can write thermal energy as heat, or else as sound. Heat and sound both are accepted here. Better you write both. Question number 2. Question number 2. Specifications of a flashlight bulb are given as 2.5 volt and 0.3 amperes. What is the power of this bulb? Power equals voltage into current. Voltage is given as 2.5 volt. You are right with the unit, and 0.3 amperes. And one more thing, one more small mistake that you could possibly do here. Listen, what is the mistake? When you are substituting correctly, you have to substitute. You are writing VI. When you are substituting, you are writing I. Understand my point? VI means voltage you have to write first, and then current you have to write. Substitution correctly should be done. If not, you won't get marks. According to a standard marking scheme, marks cannot be given. Sympathy marks can be given, but you should not be cheated by them. Standard, when you are concerning, properly you have to substitute, otherwise it's wrong. But let's say you write IB, then IB you have to substitute. Both you can write A into B, B into A, both same. But the standard for VI is V. Right? Fine. So anyhow, 2.5 into 0.3, how much is it? 0.75. 0.75 watts. Number 2. If the efficiency of emitting light from this bulb is 42%, what will happen to the remaining 50? What is happening? A bulb gives you light. Meanwhile, it is getting heated. It is getting heated. Are we using the heat from the bulb here? No, we are using the light. So only 42% efficiency, only 42% of light we are using means 58% is lost out as, right there, lost out as heat. You can't just write lost. How it is lost, you have to write lost as heat. The power of the two headlamps of a motor vehicle each at 50 watts. There are other two lamps in the rear with 10 watts each. If all these bulbs are lighted up for half an hour, calculate the quantity of electric energy spent. How do you find out the electric energy? How do you find out the electric energy? Electric energy is equal to P. Is equal to P. Okay, voltage into current into time. That means power into time. Energy spent is equal to power into time. E is equal to P into T. Okay, we learned that formula. E equals PT, because power equals E over T. E equals PT. Right? So since the power is not power is straightly given 10 watts and 50 watts. So I can write total energy consumed is equal to, first one you can see 50 watts, and how many bulbs are there? 2 bulbs are there. Rashid, right? 50 watts and working for half an hour. Half an hour means, can I write half an hour here? Then seconds. How many seconds are there? How many seconds are there? Half of 3600, right? Half of 3600. Why? 1 hour contains 3600 seconds. 60 into 60 seconds. 1 minute, 60 seconds. 60 minutes are there. 60 into 60, 3600. So 1 hour contains 3600 seconds. Half an hour means half of 3600, correct? So I'm writing half of 3600 seconds. And how many of them are there? There are plus a rear lamp is there, and there are 2 lamps, each 10 watts. So 10 watts into, again, half an hour into 3600 to make it seconds into 2. Now you can shorten this. I have written in expanded. What you can do? 50 watts into 2 you can take, and in fact the 2 watts you can separately take. 50 plus 10 you can take, because others are same. Can you see half into 3600 into 2? Half into 3600 into 2. So what you can do? 50 plus 10, 60. You have to show that. Straight away you can't write. 60, and then you can multiply by that, taking a bracket. So why I didn't write like that? In case, in this question it is not. In case, let's say, this is not half an hour, any other time given, and this is not 2, any other numbers given, then you can't write. Common multiples, only the common factors only you have to take it out. So anyhow, what is the answer here? 50 into half into 3600 is 1800. Again 2, you can cut this. So 50 into 3600, how much is it? 180? 170? No, give me the answer for this part. 18,000. Correct? Yes, 18,000. No, 180,000. Is it? 600, 50, 3 more zeros are there. 15 to 36, 180. 180,000. Okay. So 180,000 watts plus these two cut, and there it is 36,000. Correct? What is the total? 216,000. Correct? 216,000 watt seconds, joules. This should be watt seconds, watt seconds. So watt second means straight away you can write it as joules as well. Final answer, energy spent is joules. 216,000 joules. 216,000 joules. What about the question number 4? Question number 4. The current flowing through a motorcycle bulb when it is connected to a 12-volt battery is 2 amperes. How much electrical energy is spent if this current is flowing for 15 minutes? How do you find? Energy consumed. How much energy consumed? Voltage current is given, so I can use it as VIT. What is the voltage given? Voltage given 12-volt, battery ampere is 2, so 12-volt into 2 amperes, and what's the time taken? 15 minutes. 15 minutes means 15 into 60 seconds. What's the total? Yes? 40? 21,600, is it correct? 21,600 joules. 21,600 joules. 21,600 joules. Question number 5. Name 2 instruments. We didn't write that, I guess. Number 6. Consumers are charged money for the electricity used in houses. What is the unit of electric energy which is used to make electric bills? What is the unit? Can we use joules? Can we use joules here? We can't use joules. We have to use kilowatt hours. kWh. Kilowatt hours. Calculate the amount of energy in joules equivalent to 1 commercial unit. I gave that already. Okay. So that means 1 kilowatt hour you have to convert it into joules. How to convert? 1 kilowatt hour refers to 1 kilowatt into 1 hour. 1 into 1 is 1. Okay. So 1 kilowatt means how many watts are there? 1000 watts. Why do I convert that? Because joules are given in watt seconds. Okay, watt seconds are what? Converted into joules. Joule to watt second, 1 to 1 ratio. So I'm converting these kilowatts into what? Hours into seconds. 1 hour contains how many seconds? 3,600 seconds. When you multiply these, 3,600 along with 3 more zeros are there, watt seconds. That means I can write it as 3.6 into how many zeros? 10 to the power 6 joules. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. 3.6 into 10 to the power 6 joules. The question is asking you, calculate the amount of energy in joules for 1 commercial unit. If it is 2 commercial unit, you have to take it as 2 times. Okay, 1 commercial unit, you have to take 1 kilowatt into 1 hour. You are taking from here with 3.6 step. 3.6, right? 5 zeros are there, fine, but you are taking from 3.6. So you have to skip this sort. So 6 zeros. Okay. If the first 60 units are charged at a rate of 7.50, okay, 7 rupees 50 cents, and the next 30 units are charged as at 10 rupees, how much will be the electricity bill of the house where the electricity usage is 75 units in a month? Okay, the whole month 75 units only being used. Whole month 75 units are being used. So you have to find out the total monthly bill. How to find out? Question says that the first 60 units are at 7.5. Then to find out the total bill, the first 60 units are to take, right, because 60s are included within 75, right? 75 is the total consumption. within 75 only we do have the first 6. So this first 60 should be multiplied by 7.5 rupees. Okay. And then what is the remaining now? What is the remaining? Question says that next 30. But do we need to take all 30 here? No, because we are consuming up to 75. So 65 minus 75 minus 60, 15 remaining. That 15 units you have to multiply by each 10 rupees. Each 10 rupees. So what is the total you get here? This is 450 plus 150, 600 rupees. 600. Correct? Any of your house? Any of your places? Do you ever get this well? Okay. We don't. Okay. Number of times more than this. Number of times more than this. Okay. 2000. 20,000. Wow. So very effectively are using the current at home. 20,000. This may be because of no optimum usage. Not only you, in all our houses. Optimally we don't use current. I told you right last week some examples. Optimally we are not using the current. This is what happens. A lot of energies are just wasted out. Okay. Vainly of leaving it out so that current bill goes up. And moreover in our countries we don't have these rates, right? We do have a higher rate. Okay. And remember, now for an example, let me say 0 to 20 is charging at 30 rupees for an example. These are not the standard units on our country, just telling. And 21 to 40, 35, 41 to 60, 40. Then some in our country they do have a misunderstanding that. What is a misunderstanding? They say within these units you have to consume. If you go more than that, okay, unit price will be high. Unit price is high, that's true. But they are having a misunderstanding that, let's say for an example, 60 plus they are consuming. So 61 to 80, if it is charged at 50 rupees, they think that all completely, totally that is multiplied by 50 rupees. That is not. Let's say you are consuming 65 units. You are consuming 65 units. They think that completely, totally 65 units are calculated at each 50 rupees. That is not happening. That's not the way. Okay. What is the way? First 20 is at 30. As an example, according to this way. Second 20 is 35 each. Third 20 is at 40 each. So the remaining 5 is there. 65 means remaining 5, right? Only that 5 will be calculated at 50 rupees. That is how it comes. Okay. That is how it comes. But these ranges are different when you come back on. Okay. Ranges are different. You can check it. You know, we do have some applications, right? Okay. So in our country, we do have two sides. Two sides means two types of electricity providers are there. Who are they? One is CEB. The other one is LECO. LECO. CEB and LECO. So CEB is the government side. The other one is the private sector. But both of them are providing the current from the national electricity grid. That means the same plantation. Okay. In our country, basically we are producing power from the hydropower. Water's kinetic energy. That is what we converted into electric energy. So here, you see, when they are charging these amounts, they do have a certain rate. Within that only it goes. But when we consume these rates more than the ranges, and we do have a certain timing also. Some times are there, you just check it and see. Some timings are there after this time, basically evening to night. In this time period, when you are consuming more power, the cost would be very high. So if you are an efficient consumer, what are you supposed to do? You have to find out what is the most efficient time to do it. So some time periods are there where the cost is very less. So during that time period, what you can do? You can use any sort of materials, equipments to be charged. So charging equipments are there. Maybe the electric charger or the mobile phones, the batteries, whatever the sort of batteries are there you are going to use. You can charge them during that time because the cost is less. Okay? Iron to be used, washing machine to be used. You can use. So that is efficiency. Okay? But what we do, everything being consumed at night, all at once. So definitely the gonna be high. After that, electricity bill is high. We are seeing. So from the beginning, every person, every individual at home, you have to contribute. Yes. Check it out. You check it out. I know the time I am working accordingly. You check it out and do. Otherwise, you will just take it. You just leave it out. You check it, then you will be having a value on that. Then you will work accordingly. Okay. Right? There are some timings, not continuous. Some timings are there, morning and evening. Some timings are there. Okay. Fine. Anyhow, so don't get the concept in a wrong way. Range by range only it goes. Fine. Look at the next one now. And one more thing. In this question, actually, it is giving you 75 units per a month. It is given, so we can multiply. Let's say if it is giving you 75 for a week or a day, then what are you supposed to do? You have to first convert that into the month. Afterwards, only you have to find it. Is that clear? If it is given for a daily basis, you have to multiply that into 75 into 30 to get into the monthly bill. Afterwards, only you have to calculate this. Okay. So some words totally change your answer. So you have to refer them properly. Fine. Number 8. Sorry, question number 7, right? Did you write the answer for that 7th one? No? Why not? Look at the 7th question. Question number 7. A hot plate, the power of a water heater in a home is 1500 watts. This is used half an hour daily. 340 watt bulbs are used for 3 hours daily. Bulbs of 60 watts are lighted for 2 hours daily. Calculate the number of units used up in one day. So, energy consumed per day. I'm finding it out for a day. And we have to find this in kilowatt hours because it's commercial. So, how do we find it out in kilowatt hours? 1500 watts are given. 1500 I have to divide by 1000 to make it kilowatt. And how many hours it is being used up? Half an hour day. Multiplied by half an hour. Okay. Plus 340 bulb. Yeah, 340 watts bulbs are there. I'm dividing by 1000 to make it kilowatts. Multiplying by how many hours it is consumed? 3 hours. Yeah. 3 hours. What is the next one? 60 watts are there, lighted for 2 hours, 2 bulbs are there. 2 into 60 dividing by 1000 to make it kilowatts, 2 hours daily. These are the only steps, right? These are the only steps. Now we calculate it. How much is it? 1500 or 1000 means 1.5. 1.5 into half. 0.75 kilowatt hours plus 3 into 40, 120, 120 dividing by 1000, 0.12 into 3, 0.36. 0.36 kilowatt hours, correct? 2 into 60, 120 over 1000, 0.12 into 2, 0.24. What is the answer? 1.35. 1.35 kilowatt hours. This is for a day. What is the question asking you? Used up in one day. Calculate the number of units used up. First answer is done. 1.35 kilowatt hours. What's B? If electricity is charged according to the above rates given in the question 6C, what should be the monthly electricity bill? First, we want to find out the monthly bill, monthly units. Units for a month. You want to find out. That is 1.35 into 30. How much is it? 40.5 kilowatt hours. 40.5 kilowatt hours. Now what are we supposed to do? You want to find out the total bill. Now the total bill follows the previous range rate. What is the previous range? The first 60 units are charged at 7.5. This is within that. So 40.5 into 7.5 rupees. How much is it? How much? 303.75. Correct? 303.75 rupees. 303.75. This is how the answers are taken. Right? Please write them down. Those who have written already, correct. There are 8. Yes. Last day you got. Fine. Done? Done, right? So the next topic we are going up with the domestic electric circuits. I have a work with them now. Listen, before we start discussing about this point, you're gonna draw this. You are drawing this up to here. This part, hold it up this. Okay, you are drawing it now. Drawing it now. Okay, listen. Take no, it's there. Right? Take it like a landscape page on your writing book. Okay, because you have to be familiar with these gadgets. Lower part is not needed. Start from here. Use 2 color pens, red and blue. Red and blue. Use 2 color pens, red and blue. If you don't have red, any other color pens instead of red, blue color you will be having, right? Okay. Draw it completely, and if you have a black color pen, okay, no need of these pencils and all. Otherwise, you'll be finding for the pencils now. Okay. Now you say no pencils. No. Black color pen if you are having, or a pencil. Used to draw the gadgets, the equipments, the components they are in. Draw them using a pencil or a black pen. Wires as shown here. Draw them. Quickly do it. You can do it now. Draw this. Hurry please. Yeah, this all part. Lower part I have taken it out. I'm going to draw this now. What the one? Are we done? Still drawing? Almost 10 minutes I gave you. More than 10 minutes. We can fix it line. Okay. Again, looking at the line. Again, another line. He's thinking we have to connect. Then order. I'll give you 2 more minutes and then we have to discuss. Too much of time. Here. What is this? Now yeah. Water spill down. You'll take some of your materials. Right. Fine. Look at this now. That's enough time. Enough time. Home electric circuits. Stop right now. So domestic circuits, and you are taking the current supply towards your households. Here now, two sectors are there in our country to provide the supply this current. One is the CEP, the other one is the electric. Okay. And they have divided the areas according to the areas, the regions, they are providing the service. That doesn't mean that from their offices they are straight away providing the current to the house. They do have some centers, officers, institutions, they will have to maintain the intelligence. Ultimately, the current is being produced in the hydropower plants. Several hydropower plants we have in our country. Okay. What they do? The water, the flowing water's energy. When the water goes down the hill, we cross it out, and the canals are taken towards these hydropower plants, where the water flows down, passing turbine systems. When the turbines are rotated because of this flowing energy of water, it is connected with generators. So it's a huge process, simple to say. Okay. You got to remember you have done this in your lower grades, also taking yogurt cups connected with some yogurt spoons. When you connect it, when you fix it over tying up over a thread or something, and you are going to hold it below the flowing water, tap water. You can see it rotates. It rotates. When this is connected, okay, when the setup is connected with an electric generator, it produces current. When you are connecting with the bulb, you can see the bulb with the light. Okay, electric generator must be there. That's clear. Dynamo as well. Okay. So likewise, a turbine system connected generator setup they do have. It's a huge scale, and they produce energy. And the produced energy, the produced electric current here won't be having a very high voltage. But the thing is, the produced current is what to be supplied throughout the country. So what we do here, we are using some other setups to enhance this, increase this, the amount to increase. So there is a setup called transformers. What formers are they? Transformers. What they do? Transformers are used to either increase or decrease the voltage. Two types of transformers are there: step-up transformers and step-down transformers. Step-up transformers, what they do? They increase the voltage. Step-down transformers are used to decrease the voltage. So here, the produced electricity, the produced voltage will be sent throughout step-up transformers, the step-up transformers. So what they do? They will increase the voltages up to 132,000 volts. 132 kilovolts means 132,000 volts. Okay. So between this range, 132,000 to 220,000 volts ranges, it will be produced. Okay, it will be enhanced. And thereafter, it has to be transferred toward the domestic and industrial scales. So it won't be directly passing from the hydropower plants to your houses. In between, there are connections. There are sub-centers coordinating all these things. Okay, center to center, the region to region, we do have some coordination. So this the produced or developed current will be transferred into sub-centers, and in between it will be reduced up to 33 kilowatt or 11 kilowatt between this range. So what is the transformer we are using in? Step down transformer. Initially step up transformer. This may be given as a flow chart also for you to identify. Initially at the hydropower plant, we are using a step-up transformer to increase up to 132,000 to 20,000 watt. And then the sub-centers, we are using step-down transformers to reduce it up to 11,000 or 33,000 watts. And even this is not to be provided. Okay. Further, it will be reduced by another step-down transformer up to 230 watts. This 230 voltage current is what supplied towards your house. So imagine even this 230 watt current, when you are going to expose, when you are contacting them, you can feel the taste, right? So how much, what is the intensity of the current, you can see. So if such a current is given to your house, what happens? That is the last time you can see your house. Totally will be burning. And that is what happening with the current shocks, I mean the lightning shocks and all. Lightning, along with thunder, if the lightning strikes a certain place, possibly that will be totally burned. Why? It contains thousands of voltage. Okay, thousands of voltages and current it carries. That is why it's totally vanished. Okay, so the current produced should be reduced using the sub-centers up to 230 watt, and when it is produced to your house, it is produced as, it is supplied as a DC, sorry, an AC current. There are two types of current, AC and DC. What are the two types of current from now? Right. AC refers to alternating current. Alternating current. Okay, alternating current. That means it changes the direction with time. Right, left, good. Simple. Direction changes. As a circle, we are taking up and down. Okay. Positive, negative drops will be there. Direct current flows in one direction only. But we are obtaining an AC current initially. And what is the voltage? 230 volts AC current, and then it's having a frequency 50 hertz. Frequency means that is the amount of vibration, number of vibrations per second. 50 hertz refers to 50 vibrations per second. It carries by the wave when the wave is moving, because the waves are carrying energy, right? Okay. So 50 hertz. So could you please underline this statement? All these notes are there on your tube. Along with the notes, you have to go underline this. Okay. Starting with page number. What is page number? Page number 6 at the beginning, can you see? At the end of that passage, the first passage is there. But hurry up, make it fast. Underline the statement, electricity provided to houses is in the form of an alternating current AC with a frequency of 50 hertz. 50 hertz. Right. Now, when you come for this setup, a common general setup is not given here. Now, you could have seen even here, you can see outside. Some wires are hanging down, right? Large and huge cables are hanging down. You know, throughout the space, you can see it's running throughout the streets. These are the distribution wires. Distribution wires. So from the transformers, they are rising, and the distribution wires are shared among the whole region. So the distribution wire is what given as A here, and when it comes towards your house, from that distribution wire, one wire would be separately taken towards your house, towards your domestic circuit, which you term as the B supply wire. Supply wire, the supply cable. And this supply cable, when you take, it consists of two wires. The supply cable consists of two wires. One is the live wire. It is what mainly taking the current. Along with that, a coordinating wire is there, which you term as the neutral wire. So live and neutral, two wires are there in this supply cable. Live wire is basically red in color. Red in color means actually both of them are copper wires. Both of them are copper wires. Why do we use copper? In grade 10 you learned about the resistance. Can you remember? That is the barrier for the flow of current. When you come for copper, it's having a lower resistance. So the resistance less means current flow could be increased. So maximum current you can obtain using copper wires. But you have to protect the household stuffs. So you have to wrap it up. You have to cover it. You have to use an insulator, a rubber insulator we are using. So even these wires when we are taking, you can see it's wrapped up, it's covered up. So basically, okay, so this is actually the complete wire, complete wire. Inside usually we have two wires. So two wires when you are taking, the wire which is covered by red color or brown color is the live wire. Which is covered by either blue or black color, that is the neutral wire. Another wire you can see possibly in some high power consuming electric gadgets. Green or yellowish color, that is the earth wire. That is the earth wire. So these are the three wires. So here two wires are there, the supply cable consisting of one is the live, the other one is the neutral wire. Okay, and it is transmitted down at first to the overload circuit breaker. What is the breaker there? overload circuit breaker. Earlier it was used in the old houses as a service fuse. So simply there are some differences. By the way you already take the difference. Okay. Modern houses we are using the breakers. Old houses are there still where it is not renovated with this electric supply. There you can see fuses are there. Again, some movies, or you can see that if you want to completely disconnect the current in old bungalows and all, there is a small setup, gadget like structure, you have to remove it out. A white color fuse, you have to remove it. So these types are what they are earlier, what were they are earlier. But we don't have it right now. If it is renovated, or if not, still the fuses will be there. In the modern houses, we do have the breakers. In fact, all the houses might be having breakers. Okay. So with the flow, you will learn what are the differences between. So now you see, overload circuit breaker we do have here. One by one we will take later. After the overload circuit breaker, that is C, next is the electric meter. And those two are commonly taken, it will be fixed outside the home. It is not inside the home, outside. But maybe within your veranda, not inside. It is not inside the consumer level, outside. This is because of these two, you can't change or renovate or displace in your home. Because these two are belonging for whom? The electricity providers. Okay. So if you want to replace because of a renovation of your building, you have to inform them, they have to come and do that in your own. If you are doing it legally, punishable offense. Okay. So you can't touch it. That is why usually it is sealed up. Okay. Only the overload circuit breaker you can turn it on and off. That's the only thing you can do. Apart from that, nothing else you can do here. You can't change it. And there are pin is getting connected to E. E is the isolator, which we term it as the main switch. What switch it is? Main switch. Isolator. New terms are there. Isolator, main switch. Or we term it as in the old houses, it is the main fuse. Here it is the service fuse, main fuse. Okay. And then F. Next. After the main switch, who is there? The trip switch you are saying? Trip switch. Okay, that is the residual current circuit breaker, RCCB. Okay, so residual current circuit breaker, RCCB trip switch is the next one. Why we term the word dual here? We will learn. Okay, some of them are mono, some of them are dual. Mono means one, dual means two. What comes one by one when you are learning, you can take those points. Okay, and then it comes the miniature circuit breakers, MCBs. MCBs are there, a set of gadgets are there within. Okay, so these MCBs are what transferring the current, the live and neutral wires towards all the gadgets into your. Okay, so all, and then it is going towards the lighting circuits, the plug socket circuits, wherever you need the lights, lamps, whatever the instruments are there, that is supplying. So those terms are taken H as the switch here, and then I as the plug socket, earth wire goes down here, and then the lighting dot simply it is marked. Okay, so the main setups are what marked up here. This diagram could be given for you to label. So you should be able to label. Clear? Take the exams. They may give. Not everything, some of them they might take. Or a related diagram they might take and they will ask. Or else the diagram you drew. That is why I asked you to know. Using the colors why, you have to identify what is the live wire, what is the neutral wire. How it goes, how it is connected, you have to. And I will ask you a question then. If you have properly notified when you are drawing that, you can give me the answer for that question. That is why I asked you to do. Okay, fine. Anyhow, now could you please label them? Label them quickly. Up to now, if you have a question, out of what you have done, you may ask. Okay. Any other questions with the flow when you don't get, you can ask. Okay. So, what is the use of this earth? Why do we use? All we have to learn step by step. K is not there on your due, just write K and mark it. That's it. Different names, right? That means that Functions one by one. Then hurry up, please. Yeah. Ah, yeah. Yes, yes. Right. Now, so overload circuit breaker, it is the first one. After the overload circuit breaker, we do have the electric meter. And how do you name this? This is the consumer unit. What is this? Consumer unit. Consumer unit is the name for this. The white color current box you are saying, current box, consumer unit. Why consumer unit? This is inside the house. These two are outside. These two are outside. So this is what owned by the householders. This contains the main switch, trip switch, MCBs. MCBs. Okay, all the gadgets are there. After from this current box only the power supply is given for all instruments that you are using up the power connections connected over. Okay, like the light circuits, plug circuits, and all. Right. Now you see, I asked you, I told you, there's a question here. Now, have you noticed here, when you come for the overload circuit breaker, right? As a theory, let me speak about. It is not connected with both the wires. Can you see? Live wire is not connected initially. So this comes in MCBs. Live wire connects first to whom? Overload circuit breaker. Okay. Neutral wire connects first. Is it to the overload circuit breaker? It's connecting to the electric. And because of that, to pass out this, you do have a breaker. Breaker in the sense something like this. Now the switches when you are taking on, you have to tap it down, right? All these switches on the switchboard, you have to tap it down to turn it on. Tap it up to turn it on, right? But these breakers when you are taking, they do have levers like. They do have levers. Imagine it's a lever. Okay. You have to turn it up. You have to turn it up to make it on. It should be on turning up. You have to lever the lever. You have to push it up. Then it is turned on. Whenever there is a need of turning off, automatically this goes down. So moving it down, it turns off. The lever turns off. Is that clear? So turning on, you have to pull it up. So accordingly, all these breakers, they do have levers. So these levers are turned upward. So that is the difference between a usual switch and the switch gear. Usual switches, you have to tap it down to turn it on. Here you have to pull it up. Now you see, only one wire is connected, which is the live wire. So this is having only one connection. So this is called a monopole switch. What pole switch? Monopole. One connected, one wire connected switch. So overload circuit breaker is a monopole switch. Monopole switch. Okay. So what's the difference between the new and the modern? What do you call the old and the modern houses? In the modern houses, you do have this breaker. In the old houses, you got the service fuse. You got the service fuse. So the service fuse, it is something like, okay, you have a structure in this way. 2 points are there. This is what you are going to fix. And there is a mold to be getting connected. Okay, getting connected. So when you remove this, total connection is gone. Okay, that is what the service fuse basically, it is white in color. So we don't have a breaker here. There is a fuse here. There is a fuse. Okay. Now in our time, now in this time, you can obtain, you can use these fuses. Multiples are there. Wire codes are there. Some wire codes are there. You can have a small fuse. Okay, why do we have that? To control the current flowing up. More than the maximum current that can be drawn if it is taken, the fuse go off. So the wire will not be connected with the current anymore. Okay. So what is the advantage there? Your electric appliances that you are connecting to that wire won't be getting, protected. Otherwise, the large current that is flowing, that is a risk for the electric devices you are connecting over. So that there is a fuse, and then if it is burned, you have to replace it anyway. Okay. So such fuse setups are what they are, were they are in these old houses. All of them have been replaced now. We are not using the fuses anymore. We are using the breakers. So no burning of the fuses happen. Breakers are what levering, okay, up and down, depending on the current flow. When you come for the overload circuit breaker, this acts as a breaker for a maximum of 40 ampere current. What's the current? 40. That means the current is supplied along the supply cable. Current is one. Let's say if the current is exceeding 40. If in case more than 40, it is not good for our house, for our setup. So what happens here? If the entry is more than 40, this goes down. The lever goes down, turning off the circuit. So the entire powerhouse, the power system goes off. Okay. So to control the entry, this happens very rarely. Okay. So this acts as a barrier, okay, for the flow of current more than the maximum of 40 ampere. 40 ampere. Clear about that? And this is belonging for the power supplies. It is connected with only the live wire, so it is monopole. So when you turn it off, it disconnects only the live wire. Now the next one, the electric meter. Electric meter, we do have a small disc-like structure here, which will be kept on rotating. You could have seen this rotational disc. Depending on how many rotations it makes for a certain time, it is converted to units. And those units are what we are using as kilowatt hours. So this is ultimately used to record the amount of electric energy you are consuming in your domestic circuit. Okay, so measuring electric energy, recording the amount of energy you are consuming in your house is what done by electric meter. So that is why they come towards this electric meter and they are recording the number. The end of the last month's recording they do already have, right? And end of this month they are checking. They get the difference and they get how much totally you have consumed. For that value only, your bill would be calculated. Your bill would be calculated. Is that clear? Okay, fine. So now, afterwards, you see both the wires are connected to isolate, the main switch. Isolate, when you take, there are two switches here because two wires are coming. So this is called a dual pole, a dipole switch. A dual pole, a dipole switch. So what it does? This is mainly there for you to control the power supply. This is inside the house. You can control the power supply according to the requirement. If you want to totally take it off, you have to turn it off. Okay. So maybe because of repairing, renovation, or maybe because you are going out for long term, or during flooding and all. That's it. So, or you have some sort of electric repairing structures and all. So during this time, you can turn off the main switch. Okay, or do all. Okay. So in your own, you can control, and moreover, this would be also acting as a power barrier. So electric barrier more than a maximum of 30 ampere. 30 ampere. Okay, so that is isolator, the main switch. Main switch. After the isolator comes RCCB, residual current circuit breaker. So the residual current circuit breaker, when you are taking, also connected with both the wires, live and neutral. So two poles are there. It is a dipole switch, dual pole switch. Dual pole switch. Okay, a dipole, dual pole switch there. So two switches, both of them would be connected, disconnected by this RCCB. So what is the function of RCCB? RCCB will turn off automatically during an electric shock at home. Okay. So let's say there is a shock, electric shock is given for a person. Any individuals have contact with the current, maybe when they are using with any electric devices or directly somewhat contact with the current, then the RCCB goes off automatically. How it happens? Go home and try. Go home and try. Okay. If you try it, make sure you inform someone else to have a loophole. Right? Why? Because it is a long time. That is the last time you are touching you. Because 230 volts, 230 volts is not a small amount. And moreover, okay, listen. Now when you are doing that, you are wearing a rubber slip. It won't pass down because rubber slipper, it is an insulator for current. So across your body it is not pass. So what do you do? So as a second, so you are wearing slippers. Going to touch the current. The other hand is on the wall. Now dancing with the slip. Right? Anyhow, the other hand is on the wall. It passes. There should be a potential difference between your body. Okay? Potential difference should be there within your body. So in that case, anyhow there will be a current pass. So one hand is on the wall means you are giving the connection. You are giving the connection. Now let's say one person is already dancing. Dancing with the current. Now another person goes to take it. How to take it? Is it okay if you are touching? You will also dance. Allow it. Why? Current passes. Current passes. So what do you do to remove him out? Taking or what? Taking or hitting? Metal rod is it right? Right. It's a double conductor. It passes the current further. Okay. So it is not a time to take a revenge on him or herself. You have to just remove it out. Right. So just throwing it towards them won't work. You have to take the slip over your hand and you have to do it. Now again, both the hands. One hand with the slipper, the other hand without the slipper. Whatever. Anyhow it passes. Okay. Anyhow it passes. You have to remove him out using an insulator. A current insulator. A current insulator. Now you see two words are there. Thermal insulators, electric insulators. Thermal insulators, electric insulators. Thermal insulators means they won't conduct heat. Now you are learning something as heat insulators and you are going to apply that to current insulators. Can't be working on something. Okay. Heat insulators won't conduct heat. Current insulators won't conduct current. That's the reason. Okay, so anyhow, you have to remove him out. Okay, so you need at once you have to take him out. And basically, when it comes to the street currents and all, it's a huge amount of current because it's not 230 volts. And remember, it's thousands of volts. That is why basically those currents, when they are exposed, the people die. People die. Okay, so don't play with current. Don't play with current. And also, some people, when they are working out with this plugging, the plug sockets and all, they used to fix the earth wire port is there. A metal rod they put sometimes. Okay. Or sort of screwdriver they put. Screwdriver. Somewhat the other side is open, exposed, or let's say there's a enemy. You will definitely get the current. Definitely. And some kids they do that. Looking at you, they might take some other stuff and put it over there. There are people, there are kids died like. Yeah. Okay. They put the spoons inside. Okay. You have to make sure you don't keep those stuff close about the wire cords are not visible for it. Okay. The scissors, the spoon, they were totally dead. Okay. So when you are working with current, you have to be very concerned about the precautions. Otherwise, it may take your life. Okay. Right. So I say RCCBs will turn off during these electric shocks towards the resistance. Now, how to check this RCCB? How to check the RCCB? If it is working or not, going home, contacting a current supply, is it okay? Right. So I said, no, if you are contacting, it will be turning off, so I am safe. We do have a button over there. There is a button on this RCCB. You have to once in a while you have to check if it's working or not. If it's working or not, you have to check. Okay. But it is not something like on and off to play. Once in a while you have to check if it is correctly working. Okay. So RCCB works like that, and after RCCB it comes to MCBs, miniature circuit breakers. So here also breakers are there. In these setups earlier, in the old houses, we got fuses. So what is the task of fuses? if a current passing more than the maximum, okay, more than a maximum of current when it is passing, those fuses are contacted with some sort of metals, and even the service fuse when you are taking, they do have a metal, an alloy actually, a metal mixed alloy, and they do have a melting point. What point? Melting point. Now they are solid, right? Melting point means that is the level where they transform into liquid. So now we are providing electric energy to be converted into heat energy, right? Why? Electric energy when you are supplying, along with this, it is converted to heat energy as well. We are using electric energy, there is a heat loss also. Now let's say if this electric energy is increasing more than the maximum, then heat conversion is also high. This heat conversion may be passing this level. When this heat conversion passes the level, what happens? It crosses the melting point, so this melts. This melts. This is how in the service fuses in older houses, it disconnects the supply. It disconnects the supply. But the problem is, once it is molten, you can't reuse it. You have to replace it with another. So this became inconvenient. That is how, when there is a problem only, there will be a solution and there will be a renovation happening. So for that problem, they found out the solution to use these breakers. And today what we are using the breakers, maybe changing tomorrow. We don't know. Because it's getting advanced, right? Getting the technologies we are using in order to make our works easy. So one day this might be replaced with something else, where you can use all this with a click of a button. We don't know. Okay? So everything getting changed. So accordingly, we have to be updated and we have to learn. So you see, and in the fuses also the same. More than a maximum current when it is passing, the fuses burn and go over. So no more current passes. Then we have to replace the fuses. We can't use it back again. That is the inconvenience, the disadvantage we had there. So anyhow, now the MCBs are connected in such a way where you can organize and arrange the current supply towards the areas needed in your house. When you have a hall, kitchen, a washroom, a bedroom, you do have. Okay. So now, let's say you don't have this MCBs connection. MCB connections are not there. Then what happens? Whenever there is a power failure within a sort of area, you don't know where the problem is. You have to check the whole house. This disadvantage you can overcome when you are having the MCBs. Why? MCBs are connected area to area. For a hall to the hall, all the gadgets in the halls are connected by one MCB. Okay? All the gadgets in the washroom, the kitchen, bedroom, so separately when you are taking, each of them are connected separately by this MCB. So what's the advantage? Let's say the second MCB is connected with the kitchen. MCB is connected with the kitchen. Now what does MCB do? MCB turns off automatically when more than a maximum of 30 ampere current passes. So when it is exceeding the maximum current. Okay. When it is exceeding the maximum current, because more than a maximum current when it's passing, as I told you, it may transfer into more heat energy, will be allowing or will be leading towards causing a fire, resulting a fire. To avoid that firing, they go over. They go over. So this basically happening in kitchen because kitchen is the place where the women work. Is that because of that? Where most of the electric appliances are used. That is a place where we are using most of the electric appliances, isn't it? Okay, so you see, when you are using all these electric appliances, you have to make sure you don't draw out the current more than the maximum. You don't draw out the current more than the maximum. For one gadget, only one electric appliance you have to connect. Okay, so let's say somewhat the maximum current is drawing up more than 30 ampere. Now what happens? MCBs go over. Now, second one gone off, it is connected to my kitchen means exactly I know MCB, second MCB gone off, kitchen is the problem. Kitchen is the, so I have to check out only within the kitchen. So moreover, if you are having a problem within the kitchen and you are going to renovate, correct method is main switch you have to turn on. But yet you can turn off that MCB's area and then you can do your. But the exact right method is the main switch you have to turn. Okay. Is that clear? But what our electricians do, that means not practice. Two people, whenever there is a sort of issue, straight away you are taking the bulb out, you are getting the. It's very dangerous. Why? Without turning off. Without turning off the switch also you do, because remember, somewhat your hand gets touched for a 230 volt supply. You have to hang it down. Hanging over there down. Why? Current passes. Current passes. Now you may say, no sir, my hand, my legs are touching the ground. I'm over the stool. I'm over sort of, a ladder. Okay, whatever. Your the other hand might be touching over another person when you are holding up. Okay, it may be giving a potential difference. So whenever there is a potential difference, there is a possibility the current can be passing on. Is that clear? Clear about that? Okay, right. So you see, accordingly, MCBs provide the connection towards all the areas. Separate. Okay, and more. These MCBs act as a barrier for the flow of current also. Come down. I hope we can remember. I don't want to repeat it. You can remember it. Right. So MCBs work like, and all the live wires and neutral wires are taken separately, and from here there is an earth wire. Why earth wire? In case if there are MCBs, it will be protecting you from. You mean not residents. Residents are not protected by MCB. RCCB is what protecting the residents from electric shock. MCBs protect the electric devices from electric shock and from the fires arising due to overheat. So this comes in MCBs. There are two protective measures. One is MCB, the other one is RCCB. Only RCCB protects or provides protection against the electric shocks for residents, for the individuals, for the man. MCB does not. MCB provides protection towards the electric devices. Okay. Turning. Did you understand? Right. So two protective measures are there. One is RCCB, the other one is MCB. So thereafter, all these are going towards two types of circuits. One is called the lamp circuit. and the other one is the plug socket circuit. One is the lighting lamp circuit, the other one is the plug socket circuit. Lighting circuits, lamp circuit means something like this. Now these are the lighting circuits. Again, lamp circuits are this, where the lights, fan, whatever the electric device is connected directly. So this is the lighting circuit. Plug socket circuit means you can see the again they are down. They are also against they are down here. Now you can see that is a plug socket circuit where the plugins are there. Like so, these are the plug socket circuits. And two different types of circuits, they draw different amount of current. Okay, so anyhow, this is how they are connected. And the work of earth wire, if there are any electric shocks, electric leakages, to transfer the current down to the ground, that is what happening by earth wire. And this earth wire is important in high power electric gadgets are there, like in the fridge, washing machine. So those stuffs are there. So there you do have usually 3-pin plugs. Otherwise, 2-pin plugs are what there. So 3-pin plugs, the third one, the larger one at the top will be the earth one. Did you understand? Clear about that? So these are the major parts about these components. So one by one, you have to read them. So quickly, we'll go ahead. Look at the next part. Could you please read that overload circuit breaker quickly? Overload circuit breaker. Read them. I don't know. Stay on the queue. Shall I read? Look at this. Overload circuit breaker. Quickly read the points. Electricity supplied to household first passes through a fuse connected to the live cable. Underline, this fuse is arranged to allow the passage of maximum of 40 ampere current. If a larger current passes through it, the circuit breaker disconnects power to the house. Okay. And the rest of the parts you can read them. We have already discussed. Rest of the parts, make sure you read. These points you have to underline. What is given in red color? Not the topic. Okay. Can you see here? This is the service fuse. Boys. Service fuse. Right? Sorry, this one. Service fuse. Again, the black color one given here. Service fuse. And here you can see a breaker is there. The breaker. Is it in the turned on or turned off condition? It's in off. It's off because it's lowered down. When you turn it on, you have to pull it up. Okay, right. So this is the overload circuit breaker. This is the service fuse, and this part is what I told you, made up of alloy, and this is a ceramic mount. This area, it is a ceramic mount. It's not made up of metal or something. It's a ceramic mount. Okay, so it is kept over there. When it is molten, you have to replace it. Okay, that rarely happens. Electricity meter. Underline the function. The meter records the electric energy in kilowatt hours. Now this is the place where we are obtaining the reports. Okay, and as I told you last month and this month, the difference you have to calculate from here. Okay, measuring the amount, and this is the plate being rotated according to the number of rotations. Only these units are going on. Isolator, the main switch. Isolator acts as 30 ampere high current circuit breaker. Underline, more than a maximum of 30 is not allowed to pass. And also in any instances, by lowering the switch levers, you can disconnect the whole supply. Underline. And remember, isolator, when you are turning off, both L and N will be turned off. Okay, both L and N will be turned off. And you can see, isolator is capable of disconnecting both the live and neutral. So it is a dual pole switch. Underline, it is a dual pole switch. And disconnecting the domestic circuit for any repair purpose can be done turning off the isolator. So the same thing repeated with different words, because this is how that can be coming in your MCQ questions. Correct, incorrect statements. Okay. So you can see here. Can you observe a dual pole switch is what given over there? Dual pole, 2 poles are there, and this is in the new setups. Old setups you got a fuse. Can you see this is a 30 ampere fuse? More than 30 ampere current when it is trying to pass, this goes off. When this is going off, there is no current passing, and then you have to replace this. You have to replace this, and this is not happening always. Rarely it happens, but when it happens, you have to replace it. And okay, so there are dual pole here. 2 dual pole switches are there, but connected with the fuse. And that is isolator. RCCB. The purpose of RCCB is to protect the residents from electric shocks. Underline. And RCCB2, it's a dual pole switch. Dual pole switch. Now see, when there's a current leakage to the metal carrying of an appliance, the metal carrying, metal casings and all will be there. Right? So when there is a current leakage there, or else when the current is passing to the ground from the circuit, then there will be the process happening, turning off of RCCB. Next, RCCB, that is what I told you. And earlier we got, this is the setup where the RCCB works on with, and there's a resistor, okay, and there's a this button here as well. So this is how it works on. Yeah, this is the setup of this. Old houses when you are taking, there is a fuse. Probably there will be a fuse also connected over there. So simply RCCB you have to take along with this bulb, and this is also a dual pole switch, dipole switch. Now let's say RCCB gone off. There is a method you have to turn it on again. What is the method? Just pulling it up. That is not big, but that is not the way. When you want to cross the road, what are the things? Right. You never do that, right? Like this. You have to do the answer. What is that? If RCCB goes over, it is inside the house. You have to go to overload circuit. OCB you have to do. So when you go to the overload circuit breaker, you have to turn it off. That's the first thing. Then you have to come back again to RCCB. You have to turn it on. Again you have to go back to OCB. You have to turn it on. This is what is correct. But we never ever do that. It's hard. Hard. Practically it's hard, but that is a correct. Okay. Correct method is that is what our written exam. But you have to turn on the overload circuit breaker and then turning on the RCCB again turning on the overload circuit breaker. Turning on. So then only it could be work. Now let's say RCCB once again gone off. Okay. What do you do? Again and again play. Up and down. Is it? Then there is a need of consulting and home doctor. Right? So you have to consult an electrician to check it out. Okay. Now there are some occasions, where how many electricians work on still the same thing. What are the things? You are checking out with many electricians, all of them are saying nothing wrong in this. Nothing wrong in this. But still the RCCB goes over. What's the problem? No, 100% check, nothing wrong. No, 100% check. Yeah. Some points are there where the scientific world cannot give answers. It's science. Science means not only what you are learning in the book, all these includes in science. That's why we say science is. But the thing is, you don't learn. That's everything comes under that. Okay. Even maths is. That's physical science. This is particle science. Okay. Right. Say how. Some of the times you can't get the reason. With all these reasons you come. Then science won't believe in this in an unseen way. You can't believe. But there are some fields in science that we speak about. Some points are there. If the RCCB is not working, it's continuously turning over. Maybe because of some sort of, we say ghosts. Ghost is it true? Different types of ghosts are there. Different types of spirits are there. Let me ask some things are there, some things are there, we don't feel, but they are there. This is don't forget about those, right? They are there. Okay. If something is happening like that, it's a way. Something is happening which is abnormal, not normal. Then definitely, for the abnormality, there are some people treating. You have a right. Otherwise, we'll be ignorant. Explain something, right? There are some, because usually those things like they work with right? When I was saying this, someone asked me, are they using current to turn on the lights and all? They are not using current there. They use current to stay up. They use current to stay up. You may think that I'm a science engineer, I'm a science engineer. So I'm the first one should not be the one. Because science doesn't principle. You can't take all this. But I'm a science engineer as well. I have learned psychology first. When they were teaching us basic, psychology is not going to come. Some people are showing abnormal abnormalities. So whatever the medical treatment you are doing, nothing works. Then there is a time where the psychologist speaks about all the what you are doing is not working. You have to test spiritual. Psychology includes psychology is a field of science. Science doesn't accept that, but the field of science accepts it. We learn as kids, practically also we learn. Okay, you have to treat spiritually related to your tradition, culture, religion. You have to go towards the own mind. Then you can hear like the same yours. Not here. That's the point I'm speaking about the current. If something happens like that, just like showing in the movies and all, there are some things they have. RCCB goes over continuously. Because nothing works, all the effort you are putting, 8% everything you check, nothing works. Maybe there are some spiritual problems. So sometimes, when you are working on something, that I was thinking about the movies. That doesn't really like you are working on suddenly the fan is working. All the smoke and moving up and up. I have seen in my so usually even I didn't believe on all those things. I was there are I experienced afterwards I'm yeah, that is because of the scare of mobiles. I mean, they say not well, the statement. So, when you watch scared, even for a shadow, you'll be getting scared. That's the meaning of it. Okay. Likewise. So, you see, there are some, apart from that, repeatedly it is happening, you have to consult the body. Okay. You will be pick out. That up. Okay. Somewhat. Distribution. To the plug socket circuits. Okay. To the plug socket circuits, maximum of 13 ampere current can be 13 ampere current can be given. So, if you want to put up a plug socket, definitely you have to draw the wire which can give 13 ampere current. So, this is in the modern houses, 6 ampere. Old houses, old circuits, plug socket carries 15 amperes and the lighting circuits carry 5 amperes. 5 amperes. Okay, right. So that is what given. I will give it as a note. So you see, plug circuits are connected to places such as in the kitchen that have devices like electric heaters and electric ovens that consume a large amount of current. So now this diagram comes in question that was there in previous papers. Given this diagram, they are asking you to label it. So this is the bus bar. What bar? Bus bars. Two bus bars are there. One is for the live wire, the other one is for the neutral wire. That is the connection through that only the wires are transferring on. And these are the MCBs. Again, switch levers are there. And this is how it was in the previous setup, where the fuses are there. Can you see? Instead of the levers, here we do have the levers. Instead of the levers, earlier we got fuses. If the fuses are turning off, that is because of throughout that particular lever, sorry, the particular fuse, current is more than maximum. Okay, then we have to, renovate and we have to rearrange them. Right. So now, light circuits, that means the lamp circuits. And then the plug socket circuits. We write it down on a writing book. Light circuits, when we are taking, this is in the new house that I am speaking about, the modern ones. We got MCBs. We are having MCBs. So 6 amp current is what provided, and here 13 amp current. 13 amp current. And you see here, when you come for light circuits, guys, look here, we can connect lamps and 2 6 ampere plug sockets can be connected in. That means, look at this. Look here. Comes in MCBs. When you come for a light circuit, lamps, it is a common word given for all the connections. The lights, fans, everything. So any lamps, any switches you can connect over this light circuit. They are the direct tapping on off is given. Along with that, 2 plug sockets you can connect. And each plug socket contains 6 ampere current. Okay. So you see, if there is any plug socket in your house where you can obtain only 6 amp current, that is not a major plug socket, that is a part of the lighting circuit. You understand? If it is drawing a maximum of 6 ampere current, that is not a major plug socket, then it is a part of the lighting lamp circuit. Because the major plug sockets when you are coming, it draws a maximum of 30 ampere current. 13 ampere current. 13 ampere current. And whom you can connect? You can connect plug sockets only. Only the sockets you can connect. You can't connect the lamps here. You can't connect the lamps. And also, when you come for the old houses, you got fuses. 5 ampere was the fuse in light circuits and 15 amperes were there in plug sockets. And the wires when we are speaking about, the wire connection, through the wires only the current is through. Wires when we are taking, these wires are single wires. Single wires. And these single wires are about 1.0 millimeter square. That is the surface area. Area is 1 square millimeters. 1 millimeter square surface area. Okay. Cross-sectional area. And the diameter is about 1.13 meters. What is the diameter? 1.13 meters. Comes in MCBs. Okay. So this is in the light circuits. Plug socket circuits, they have to carry 13 ampere current, right? So we have a cable consisting of 7 wires. How many wires are there? 7 smaller wires are there connected together, but it is covered with. It seems to be like one cable. It contains 7 smaller wires, and here the area is about 1.5 square millimeters. Diameter is not spoken about. Okay, so this is the difference between the cross-sectional areas. Clear? So this speaks about many theories related to light circuit and plug socket circuit. Note it down, please. Yes, write a book. Write a book. Hurry up, please. Done. 1.13 millimeters, not meters. 1.13 millimeters. Hurry up, please, hurry up. Page number 6, there are 2 lines of right now. The service cable consisting of the supply cable consisting of 2 wires. Click on page number 2. Will write that, no? Page number 2 on your keyboard. There are 2 lines at the bottom. Can you see? This is page number 2. Page number 6. Page number 6. Sorry, page number 6. 2 lines are there close to the diagonal. Click up. Live wire, capital L, neutral wire, capital N. That's a symbol. Live wire, neutral wire. Live wire and neutral wire. Not like men, like. What the is down? Shall we go next? Miniature circuit breakers. We already discussed about that. Underline the function. Underline the function. When a current larger than the maximum current that can pass through the circuit is true, miniature circuit breakers automatically get disconnected and the lever shifts down to the off position. And all what is given here, that is what I have given you in a compare that. Okay. MCBs, we are using these levers. Earlier we used the fuses along with these metal alloys. Okay, that's the difference. And when these MCBs are connected, always they have to be connected with these live wires so that the current passing wire can be controlled. Distribution boxes. MCBs provide protection against electric shorts and resulting fires due to heated cables only. Underline. It is not providing protection against the electric shocks for residents. Okay. So people when they are getting an electric shock, there is no protection. In modern domestic circuits, RCCB isolator distribution box are included in the same unit, which is called the consumer unit. That the white color box. current box, that is the consumer unit. So this is the consumer unit. What is this? Main switch, mid switch, MCBs. MCBs. Go home and play it with. Check it out. Check it out. How to check? Turn it on and off. But before that, make sure none of the devices are connected. Mother is already connected to the grinder. You are going to grinder comes to the base. Okay. So make sure nothing's on. Nothing's on. Just turn it off and make sure nothing's on means let's say a computer. It's connected. Computer, how to directly connect, right? While it is connected, you are turning off the computer connected area. What happens? There will be a reaction isolator too. Okay. So those things are concerned. Okay. And also don't play fool. Don't you write like a piano you are going to work out. Don't do that. One by one. Just check it. Okay. But properly I'm saying if you are checking, do it properly. Don't use my name doing wrong. Okay. So reaction will be coming from there to mine. So main switch also the same. Don't just turn it on. Check it out. If there is any sort of things connected. Otherwise, wrong ways when you are doing it. Let's say the ceiling fan is turned on at once you are going to work out with the main switch. Again, it might not be working because of sudden stop. Again, an unexpected way. Maybe, resulting like. Fine. Moreover, I told you when you are drawing out the current, okay, we are connecting the multiplugs, right? Why are we connecting multiplugs? 3 ports will be there, all 3 we can use. Okay. Now, even all 3 when you are using a multi-port, when you are using a washing machine is also connected. Fridge is also connected to the sink. Okay. And the oven is also connected, and when you are starting with the grinder, all gone. Why? All of them. That's what people they do. All of them are, high power consuming. So they all go off. If it is having a fuse connected multi-port, somewhat there is a protection. If not, problems arise. Like this. People they use like this. Now what happened? Now otherwise you may think, so 13 ampere means anyhow, 13 ampere means anyhow. Maximum current is 6 amperes. Maximum current is 6 amperes. But when you are connecting like this, all of these devices need like, so it's something like imagine 1 quart of water pipe is there. That the water pipe, it does have a certain maximum volume that can flow out from the tank. Now, number of wires you are connecting separately. Imagine somebody who connected several wires and all of them are drawing out water. Total water becomes more than the maximum. Then what happens? Tank gets emptied quickly. Or else the pressure over there will increase. Where the port can be damaged. Likewise, when all these appliances they are drawing out more and more current, more than the maximum of 6 ampere, it may burn here. There would be a heating. There would be a heating that the heat will be turned into a firing. It may burn and it may blast. That happens especially in mobile phones. Mobile phones for a long time. High power when you are taking on, already it's connected. You are using what they call the earphones, and it is connected to the charger. Everything else for a long time it gets heat. It gets heat. So avoid those things. Avoid especially these stuffs. Okay, right. And furthermore about the switches and all the same thing given. Have a look at the tune. Oh, that's right. Switches and the plug sockets. Switches. Now we will end up it. Switches. Maybe a single switch. 4 switches are there. This is a plug socket circuit. This is the earth coil. Okay. These 2 are the live and neutral. How do you find it? How do you find it? Look at this. When you're gonna connect it in this way using these 3 fingers, you're connecting like. Can you see? This is the way you are going to connect. This is N, neutral, earth, and L, live. So they are the 3. They are the 3 fingers here. You're going to use it up. Okay. N-E-L. N-E-L. Nel. If you're gonna use it like this, Nel. If you are coming towards your face, Len. It's coming towards your face, Len. L-E-N. Going away from, you're going to fix it. It is N-E-L. Okay, because we're changing that lateral inversion happens, right? Okay. So N-E-L, neutral, earth, live. Neutral, earth, live. This comes in question. If you get diagram, they ask you to label. Okay. And when you come for a 2-pin plug, basically earth wire is not there, and that is covered totally with insulator. a current insulator, no metals are there, rubber setups are there, and they don't want an earth wire because they are used in smaller, small current consuming electric gadgets. Connecting wires already we spoke about, and I told you red color or brown color is what used, and today we are using brown. And that is for light wire. Neutral wire or blue color wire we are using. Earlier it was black color. Earlier it was black, and here earlier it was red color. Earth wire green, yellow. And such circuits are also there. Listen, it is called a loop circuit. This is called a loop circuit. Ring circuits like we are connecting. Okay, number of circuits as a ring we are connecting. So this is called a loop circuits. Apart from that, all the setups, all the equipments, all the lightings are connected in our domestic circuit parallelly. How is the connection? There is no series connection. Apart from when we need special general setup is parallel. Why parallel? So that voltage can be maintained the same. Because voltage you want to maintain same, circuit should be parallel connected. In parallel connection, voltages are equal. Voltages are equal. So all the gadgets to obtain with 230 voltage, all of them are connected parallel. All of them are connected parallel. So I have to remember that. So underline this. Each bulb and each plug in domestic circuit is connected in parallel to one another. Parallel to one another. Specifically, you can make it series. These are general setups. Protective measures in domestic circuits. There are two protective measures. Write that down. RCCB, residual current circuit breakers. MCBs, miniature circuit breakers. RCCB, MCB. And RCCB we learn. If there is an electric shock, okay, or a current leakage in the electric appliance, RCCB goes off when they are contacted. Okay. MCBs, that is already I think highlighted. In MCBs, what happens? More than a maximum current is passing, okay, then it will be turning off. It would be turning off. And if there is a power connection, this is what I told you. Going to OCB, RCCB, that setup is not given here. The last one, just 5 minutes more. 5 minutes more. 5 minutes. 5 minutes. Only fuses appropriate. Now, it says that according to the maximum current, you have to connect the setups as well. 6 ampere current circuit, only 6 ampere within that range only you have to connect. More than that, up to 13 amperes, you can go for plug socket circuits. Plug socket circuits. And moreover, just like I have shown the image earlier, you should not connect one over the other to draw more current where they may result in burning and resulting in fire. And this is what it says, plug socket when you are connecting, limited ones only you have to connect. More appliances you connect, there is a risk for those electric appliances as well. Only plug suitable for plug socket should be inserted. Now, plug socket when you are going to connect it with it. Most of the time, the 2-pin plugs also are going to connect with this 3-pin plug socket side. Usually, we have 3-pin plug socket side. So, what do you do? You are going to insert a rod. I told you. The pencil is fine, but the thing is, the pencil either side should not be exposed. Why? It is a carbon made, a graphite made rod. Which can conduct electricity. So, if you are contacting, both the ends are open, one is to the current, the other one is on your hand, means you will feel the current. Okay, you feel the current. Okay. So, proper setup you have to use. And sometimes what they do, two wires are there. Electricians they know how to make it. You are going to connect the wires directly. Okay. You don't know how it works. Going to directly connect it. With that you will be done. Okay, because I told you maybe areas exposed out. Maybe there are areas exposed out. It may be contacting where in what you are getting, passing out the current. Okay. And ironing and all. Better wear these rubber slippers, rubber carpets beneath the feet. When you are applying, there want to current passing even if there is a leak. But you know there is a leakage and still you are having the rubber carpet and putting your life on it. It's not working. It won't work. There is you know there is a leakage on that current gadget. You have to repair. Okay, you have to repair because maybe the same current leaking out, but continuously when it is happening, there will be a burning because it's heating up. And changing bulbs, especially in the washrooms, especially in the bathrooms. You are going to turn out, turn on. You are going to change a bulb. Okay. Why it is turned on? With your wet hands. What happens? Right? You will be getting the shock from the bottom. Okay. And more, it's good to use a mat in front of a refrigerator. Why is that? Some places you could see there's a mat in front of the refrigerator. Or behind the refrigerator, they used to keep a space between the wall. Why is that? Wall will be getting cool. Okay. Why? Heat loss means something like this. Now, in this, fridge gets contacted with another surface which is getting frequently heated. That heat would be also taken to the fridge. Then taking that heat to the fridge, that heat should be also cooled down. Then they are using a double of electric energy to convert. So the consumption of the units will be increased there and the efficiency will be reduced. That is why you have to give a gap. And when you are not using these any electric appliances, you have to make sure they are kept turned off. Kept turned off because during a sudden maybe you are some electric failure. All island, right? So if there is a failure like that and suddenly it is given off, a large amount of current enters. At that time, if any precautions are not there, there may be there is a possibility that the electric devices go over. And that happens usually at home. Suddenly when it is turned on, sometimes the electric devices go damaged. Okay, that happens because of you don't keep them turned on. Anyhow, you turn it on and you plug it in. There is no current passing because already it's selected. But a huge amount of current passing on, it may be getting heated up. Because of that, this may result in damage. And during the lightning strikes and all, again, especially when you are using these radios, mobile phones and all, already connected with the connected to the mobile and this is connected to the charge. Mother was shouting at you, turn it off, you don't listen because it's already connected. And higher volume, lightning sound you can't hear. Whatever. In case the lightning passes down the charge, totally turn into ashes. There are people dying. Many people. Okay. Make sure, okay, before you using that, if you have any last wish for something, inform it. You are doing that something like a suicide because you know that is not good to do. If you are doing it, something like a suicide. Okay, you are suiciding yourself. Right. During a power failure, switches of electric appliances, you have to turn it off. And you see, now, sudden emergency cases may be arising like a firing. Emergency fires may be there. Then what are you supposed to do? You have to turn off the overload circuit breaker. Do you know where the overload circuit breaker is in your home? So go home, take it out. Fine. Suddenly, if there is some sort of thing, you have to turn off the overload circuit breaker. You can turn off the overload circuit breaker of your neighbor's home. Because you don't know where you are. Okay? You have to. You should do. Okay? So overload circuit breaker, you are turning off the entire current circuit, you can turn over. Right? And any installing power setups or any sort of repairs should be done by a trained electrician. You don't become an electrician. Moreover, checking out with this RCCB frequently, you have to test if it is working or not. So just smaller precautions are given. Furthermore, practically you can see in your day-to-day activities. So that's the end of the lesson. So two parts we divided. One, calculations. Two major equations you have learned. We did the questions asked today. And the second part goes up with the domestic electric circuit components. Remember the components along with their structures and functions and the differences comparison between. Any questions? There was a question. When you hit here, suddenly you feel like a spark. After, why is it? Do you have current inside your body? You have electric charges inside your body. And when you are hitting over there, when you are giving a vibration over there, sometimes it won't be happening in everyone's body. And even the same individual, always it won't happen. Suddenly when you hit, if it is contacting with the nerve, Nerves are transmitting the impulses as signals, plus minus charge. So because of this sudden vibration you are getting, there will be a change happening within the potential. So it seems to be like a current flowing. Can you use that to turn on a light bulb? Right. So it's not a current light, but not a current light means because of these charges only, when you are contacting with the current exposure, the current passes. Because of the possibilities are given. These plus minus ions, and even in your blood there are plus minus ions, they are what transmit. That is how you are contact. You become a contact. Okay. That means, like two terminals are there. Two terminals are there where you have to pass the current. There you have to pass the current. Both ends when you are contacting like this, current can be transmitted. But you want the current can be transferred. Right? Through your body, current can be transferred. Okay. But you won't be alive to see that because the huge amount of current passing through your body. So possibility is there. Did you understand? Any other questions in this lesson? Any other questions? No. Shall I end up there? Wait. 2 minutes. Wait. 2 information. 1. Next week, okay, you have work to be done. You are planning out with a sort of documentation and experiment, okay, related to science. So everyone here must participate. Must with no excuses. Here's a project. It's a project to be done. Listen, don't ask me again. Going home, don't send me messages. I'll call you. Okay. So don't send me messages. Going listen. Okay. So we have to make a project under the theme science. No specific topics I'm giving you because you have to search. Grade 9, grade 10, grade 11, any scientific lessons or any scientific word related stuff. Okay. Right? You can pick up a topic you have to make and you have to give me a proposal next week. Project proposal. Project proposal you have to that's always I don't know what like that here. Right? So a project proposal you have to give me minimum 3 pages every. It's a proposal only, not a project. 3 pages. First page you are 8 pages. With the column. Second page and third page, you have to put the topic. What is the topic you are choosing? Example, bacterial genetic. What was the example? Don't take the same thing everyone. Okay. Take the topic. What are the materials you need for the activity? That means what you can do only how to say. Selecting an activity related to mass. Can you do this? But what you can do within the way you have to say. Isn't it? So materials needed you have to write. And the steps, how do you plan it? Because how do you know how to plan it? Where do you get the materials? Okay. What are the information sources? Where you get the resources or source information from? If it's the website or something, that's all right. Okay. And the model. What are you going to make? What are you going to make the model diagram you have to do, or else you have to paste. Okay. This is the only thing you have to do it next week. But it's must with no reasons. Okay. No reasons. Wedding, funeral, family function, event, school, competitions, exhibitions, those things are okay. Okay. Sports meet, no excuses. Okay. No excuses. You have 7 days. Okay. You have 7 days. 7 into 24 hours. Okay. You have to just spend maximum of 3 to 4 hours. 3 to 4 hours completely to plan it, write it, and so within science, no any other subjects. Within science, within the scientific world, any theories you can take. What you know, what you don't know, don't know. And you have to proceed, you have to write how you are going to proceed it, how you are going to represent it. Because you have to make it and you're gonna have it on. Next week you are going to give me that. I will upload that next week, checking out, and if there are any corrections, I will inform you. Okay, and then I write what you want to do. But A to Z you can't ask me. Just writing, copying down from the internet, check GPT. Very much. Writing just the topic, everything it comes, you are writing and coming up with, may I ask you first question. Check GPT want to that and then so I have to answer me. So get this guy accordingly, get the sources. Next week you are submit. 2 weeks time you are having 31st of this month we will have the within grade 9, 10, 11. As a competition goes, as an exhibition runs out, there will be selected people winning out. Okay, as a competition. Okay, this is the motive of this is to enhance your skills in identifying and working out these experiments. Okay, and also everyone wants to be in the same rate. Each one would be choosing different. Okay. So you can learn everything on that particular thing. If you do one thing, others are doing some other experiments. So all you people can learn everything within that day. So gonna be happening between grade 9 and 11, and the timing, how it's gonna happen, everything we plan it, confirm it. But I need everyone's participation coming next week. Don't say mother father asking me to go this. They are here. They are having a plan, family. No experience. Nothing. Yeah, I know. I have also planning to. Nothing. So say it was not a people. Also, if you are not playing that one, that is not something I want to. Let it happen. You come. Why? If you are not playing, will it be coming behind? No, right? If you are staying at home, you can say, "Oh, this new, there is no. You don't want to stay only at that day." Okay, right? So don't give me excuses, please. Definitely out of participation. No, I need individual. But if we are doing individual things, anyhow, next week I will see how the group work goes on. Individually after that, you must be able to explain what happened in your setup. You have to explain. Get me the project proposal next week. Don't come up with any reasons. I did sir, it is in Denmark and pass. Why? They are the one who give the approval rate. Don't give me excuses. Reaction you can see next week. That's clear? Please do complete it. Half of it don't come. I'm not there to complete it right. You have to give me the completed one. So I tried, so I don't know the next one. No. You have to circle, you have to complete it. And moreover, another competition also I'm planning on. Related to videos. So you know, you do have that skill right? AI, using AI. AI, but I just confirm it. Planning it up with AI video like a competition to forward, giving a topic, giving a theme, how to get prepared within this time period, you have to do it. That's what we confirm. Okay, this is confirmed. We'll be having inshallah. Get prepared accordingly. That's one. And 17. This was the 31st Thursday. 31st Thursday. 31st Thursday. Morning onwards will be having. I'll confirm the day. Saturday class will be usually done. 17th Thursday is a point. 17th Thursday is also a point. Okay. On that day, listen, 2 seminars are there. One is for grade 10 and one is for grade 11. Anyone needed to join? For grade 10, anyone needed? That is the changes in matter 16 chapter. Listen. Some of you people haven't done that. If anyone want, they can do that. Special for grade 10, grade 11 course can attend. Okay. That is from 9:30 to 1. Changes in matter. Equations, those are 2 to 5, grade 11, one seminar you have. That is for the calculations form. Unit 8, 9, 10. Unit 8, 9, 10. Okay. Heat changes, heat, and then electricity. So those 3 topics should be taken as question and answers. So that would be from probably 2 to 5. Okay. Once the files are ready, you will be getting on. You have to make recordings. Okay. Did you understand? Right. And the third info, I told you to get prepared for an online exam. Okay. I thought to have it tomorrow. I thought to get prepared. Last week I told, isn't it? Last week I told. And last week itself I told, suddenly I will say tomorrow I will say it. The same thing I'm saying. Yeah, no. Tomorrow Sunday is better. We can have it tomorrow. Can you all do it? Maybe like around 8. No, you don't have any class at the time. Sunday. 8 o'clock, like 8. Have class? Good morning, good morning. Morning, you will sleeping in. Like some sleeping time. 8 o'clock, like you will start. 8 to 8:30, like just half an hour, but you already sit there. Can you all do it? You do learn? Within the first 5 chapters? Within the first 5 chapters. Okay, just half an hour question paper. Okay. MCQs like make it on. And tomorrow 8 to 8:30. Half an hour. And you have to log in with the online virtual classroom. Okay. I told you already. Get prepared with. Okay. And at that moment, 8:30, 8:29, send me messages. How to name the profile. I will give nice name. Okay. So don't send me any messages at that time. Get prepared. Then is it okay? Okay. So get prepared accordingly. Don't send me any message. I want answer in message. So free information I gave you. Quickly, don't send me messages asking what is that. Okay, fine. Random now. We'll start at 5:20. The paper comes. 5:20. Finish up the prayers and come. Coming here, don't ask me time again, okay? Come up with the proposal. 8 and 9 o'clock. I got that.